rotational platform has been opened. In moments, the Long March 5B will lift off.
The rocket will be carrying the Tianhe core module to space, the foundation elements of China's planned orbital space station. This launch will kick off a flurry of the missions to establish China's Tiangong space station by the end of 2022.
And now scientists and engineers are making last-minute preparations for the core module's maiden flight, which is to take off at Wenchang Space Launch Site in South China's Hainan province. And hello and welcome to our special coverage of China's space mission on CGTN. I'm Li Qiuyuan.
And I'm Yan Zhao. And China has ambitious plans for its space programs to be carried out by the end of next year. It's expected to conduct 11 missions. That includes 4 crew spaceship flights, 4 cargo spaceship flights, as well as launching 3 space station modules. Tianhe core module is the first major mission on the list. The missions are part of China's larger goal to complete the building of its first space station by around 2022.
And Tianhe's journey is made possible by its launch vehicle, the Long March 5B Y2 rocket. It's a new member of the Long March 5 family of rocket carriers. The deployment of the rocket carriers are part of the country's ambitions to explore outer space.
This moment took nearly 10 years. The Long March 5B project was officially approved in November 2011 to undertake the task of launching modules of China's planned space station. From its preliminary development stage, it moved into trial development stage 7 years later. The Long March 5B Y1 passed factory evaluation in January 2020. On May 5th, it successfully lifted off from the Wenchang Space Launch Center in Hainan province. In February this year, development of the Long March 5B Y2 was completed and delivered to Wenchang. On April 23rd, it was transferred along with the Tianhe to the launch pad, where it awaits another countdown to China's space exploration ambitions. Specially developed for the construction of China's space, the Long March 5B is nearly 54 meters in height, about the size of an 18-story building. Its cowling is 20.5 meters in height, with a diameter of 5.2 meters, the biggest of its kind in the country at present. The Long March 5B runs on clean fuels like liquid hydrogen and oxygen. It has the biggest boost power in the Long March 5 families, making it possible for China to launch bigger spacecraft.
The Long March 5B rocket can deliver 22 tons of payload at a time to low Earth orbits. It has the largest carrying capacity among China's existing rockets and is among the leaders in this category of rockets in the world.
Compared with the Long March 5 rocket, which is like a long-distance runner launching satellites to further distances in the universe, the Long March 5B rocket is akin to a sprinter with strong explosive power.
Deep space exploration missions, such as large-scale communication satellites and probes to Mars and the Moon, are completed by the Long March 5 rocket. The Long March 5B rocket mainly undertakes launch missions for the space station and its modules to low Earth orbits.
The Long March 5B rocket is among China's new generation launch vehicles. It reflects the progress of the country's space engineering over the past decade. Experts say technology behind the 5B lays the groundwork for the development of heavier launch vehicles in the future.
Well, joining us in the studio is Professor Yang Yuguang from China Aerospace Science and Industry Cooperation. And we have another guest via video link, Xu Yansong, the Director General in Asia Pacific Space Cooperation Organization. Welcome you both.
Now, let me start with you, Professor Yang. Talk to us a little bit about this rocket, right? What is the carrying capacity of this Long March 5B carrier rocket?
As you mentioned, Long March 5B is a new new member of the Long March 5 family. The original version of Long March 5 has 2.5 stages, which is mainly used to launch high-altitude orbit payloads, such as geosynchronous orbit satellites, such as the lunar probes or the Martian probes. So for the low Earth orbit, it's not feasible to launch heavy payloads more than 20 tons. So this Long March 5B is a derivative of Long March 5, which only have 1.5 stage. But the payload fairing is very big to put the space station in. The payload fairing is long more than 20 meters, and the capability is, as mentioned, 25 tons to the low Earth orbit.
So a simpler structure, but a higher reliability, isn't it?
Well, yeah, I got this question from Mr. Xu. So we have to watch the Long March 5 and the Long March 5B have for this test of flight. Can you tell us both of them are it's a Long March 5 family. So what is the difference between them?
Well, the Long March 5B basically is a simplified version for the low Earth orbit capabilities. As Professor Yang mentioned, Long March 5 was for geosynchronous and deep space missions. Long March 5B basically removed the second stage, which plays a role for a higher altitude. So that also enabled the rocket to have a larger fairing, a larger capability to low Earth orbit with a single stage launch. So that is this fundamental difference between the 5 and the 5B.
And Professor Yang, this rocket is the most powerful rocket that China has ever had. Why do we need the Long March 5B carrier rocket for this particular mission?
You're correct. Long March 5B is the largest launch vehicle for China to launch low Earth orbit payloads. Actually speaking, it is third largest rocket in the world. The most powerful is Falcon Heavy. The second is Delta IV Heavy. The Falcon Heavy has a payload capability to low Earth orbit of about 63 tons, and the Delta IV Heavy has a capability of 28 tons. While our Long March 5B is the top 3 launch vehicle in the world, have a capability of 25 tons. You know that our space station is composed of 3 modules in the initial stage: the Tianhe core module, the Wentian experimental module, and the Mengtian experimental module. All these 3 modules has a mass of more than 22 tons. So we don't have other choices. We can only use the Long March 5B to launch these 3 modules into space and combine them together to construct the station.
Well, thank you, Dr. Yan. And for the latest, let's go to our reporter Ning Hong at Wenchang spacecraft launch site. Hello, Ning Hong, and how are the preparations going so far?
Hello. Well, yes, now we're in a platform very close to the launch pad, and the rocket is about roughly 3 kilometers in front of the launch pad. You can see now the rocket and the service platform is now open. The rocket, we have learned that the propellants now have been added into the orbit, into the rocket. You can see that there are vapors showing beside the rocket. That's because it is using the low temperature liquid propellants, and it's now people need to fill the propellants, continue filling it until before the launch. And we're now about half an hour before the launch, and you can see that this is a very open platform. We could see directly, see the launch pad, and also this is the rocket that carrying the core module of China's space station, the Tianhe, and we'll soon entering a new era where China will have its own space station. And also the rocket now they're using is the Long March 5B rocket. Like you said, it's a specially made rocket for to sending modules like a spacecraft into the orbit, low Earth orbit. And also in the meantime, we have learned that the weather here today is not very good, but it's a little bit cloudy, a little bit windy, but it seems that, well, people are confident about the launch. So the launch is very likely to be continued, and it will be launched about half an hour from now on.
Well, thank you, Ning Hong. That's our reporter from the Wenchang Spacecraft Launch Center. And now let's get back to our studio interview with. So I got this question for Mr. Xu. So we have noticed that the Long March 5B carrier rocket has the super large payload fairing, and why is that?
Well, basically because of the space station is large, but traditionally we have 3.35 diameter launch vehicle. This is basically due to the limitations that we have launch site inland in China, limited by the railway capabilities and tunnels, that we have to limit the fairing. So the Long March 5B has the longest and largest fairing so far. The dimension is over 22 meters long for the fairing only, and it's more than 5 meter diameter. So it's capable of engulfing the maximum dimension of the Tianhe segment, and also future missions, as Professor Yang mentioned, Mengtian and Wentian. So those are three largest segments, like the human body and both arms of the station. So it is largely due to the dimension required.
Yes, in a later we're going to see that super long fairing that is long as over 20 meters. It's that's the super one.
That is very critical. And you were just watching live pictures coming from that Wenchang spacecraft launch site. But Mr. Yang, let me bring you into this. There's a bit of green technology involved in the fuels, right? Talk to us about the clean fuels that the rocket is going to use.
Yes, you know that Long March 5 family is called the new generation of China's launch vehicles. Before that is currently in service is Long March 2, 3, and 4 series. All these launch vehicles use UDMH, or unsymmetrical dimethyl hydrazine, as the fuel, and use nitrogen tetroxide as the oxidizer. The UDMH is highly toxic, and the NTO, or the nitrogen dioxide, is highly corrosive. So all these are toxic fuels, toxic propellants during the past. Well, our new generation, including this Long March 5, use cryogenic propulsion system. The 4 boosters use the kerosene as the fuel and use oxygen as the outsider, while the core stage of Long March 5 or Long March 5B use the liquid hydrogen as the fuel and use liquid oxygen as the oxidizer. So you see kerosene, liquid oxygen, and the liquid hydrogen are all environmental friendly, no toxic and no corrosive components. So you see that this will be more friendly to Earth and more easy to use. But on the other hand, it also brings some difficulties. You see that liquid hydrogen and the liquid oxygen must be being kept in a very low temperature. So it requires, it raises a very high requirement to the launch pad and to the launch procedure. You may see the white smokes or the white fog coming out from the vehicle itself. That is vaporized liquid oxygen.
And we were having that shot of the countdown clock. We're just 40 minutes away from the launch, and you were seeing the shot of the command center. People are doing these final preparations. And Mr. Xu, how does the Long March 5 compare with other heavy lift rockets that are in operation now? We're having this great view of this Long March 5 rocket at the launch pad now.
Yes, the Long March 5 has, like Professor Yang mentioned, its unique characters. Use the liquid kerosene as the strapped-on boosters. As you can see, the total configuration, there are 4 strapped-on boosters along with the centerpiece, which is YF77 liquid hydrogen and oxygen engine. So this is a character that when you launch, you use the kerosene as propellant in the atmosphere. So compared with other vehicles, we have upgraded the centerpiece, which is the core engine, into a liquid oxygen and liquid hydrogen, which has a better ratio in propulsion once it enters outer space. So the rocket is very efficient and also environmental friendly, as Professor Yang mentioned. The Hainan launching site is built for such a fuel only. So UDMH and nitrogen tetroxide is not part of the plan for Hainan, only kerosene and oxygen. So it's very clean and also very efficient rocket.
Yes, this is a new type of fuel that we are using in the Long March 5B is more environmental friendly. We go ahead. What can we expect from China's next heavy lift carrier rocket, Dr. Yang?
Well, you see that the leaders of China Aerospace has expressed their wish to have human missions to the moon in the future.
Yep.
And also in just after the 2 sessions of this year has announced that we have the plan to have the human missions in the future. So we now is in the stage of key technology preparation. So you see that we already have some tests about the 10-meter module of the core stage of the future super heavy launch vehicle, and also the 500-ton level thrust rocket engines, which is in development. So you can sooner or later we can have this heavy launch vehicle to prepare for our astronauts to walk on the moon.
Yes, Mr. Xu, are we going to expect it to see some more heavier and bigger and larger rocket in China in the future?
I'm sure we're going to see that because we have already invested in the evaluation and assessment of the launch vehicle. We have to find the appropriate purpose for the development of such a vehicle. For example, our human missions to the moon and beyond. So the heavy lifting, what we call it Long March 9 sometimes, is twice as height as of what we're going to see. We're seeing now. This rocket we're seeing, Long March 5B, is only 53.7 meters in height, but the new generation Long March 9, let's call it for now, it would be more than 97 meters. It's almost 100 meters tall and 10 meters in diameter. So it's twice the size of this Long March 5 series. So we do look forward to see that in a decade time or even less, because critical technologies are being tested and evaluated. And once we have that, I'm sure the human missions and more ambitious programs will be implemented.
All right, we were seeing the monitors showing the humidity, the temperatures at the launch site, and we were just less than 35 minutes to go till the launch. But Professor Yang, it looks like we're having a bit of overcast sky there. Is it an ideal climate or weather for the launch?
That doesn't have much influence to our launch. You see that for launch procedure, there are many conditions we must meet. For instance, there should not be thunder and lightning during the trajectory of the rocket. And also, before the launch, the wind should also be well monitored, because the wind have very great influence during the flight. And also, you see that because until now, the human being cannot go into orbit with only one single stage, so we need to drop our stages in the sea or in the land. For this Wenchang spacecraft launch site, our boosters, our payload fairings of this Long March 5B will drop into the sea. So before the launch, we should see we should confirm that during the dropping areas there is no any vehicles, either ships or planes, coming through this area. So we must keep this safe, and also we must ensure that other systems, for instance, such as the telecommunication and tracking system, is okay. We have ground stations and also have space tracking systems. All must be in good condition.
All right, Dr. Yang and Dr. Xu, stay with us. Now, China is set to launch the core module of its first space station today, as we've been talking about. And CGTN's reporter Yo Yang takes a look at a model to show us what it looks like and how it was developed.
As the main control cabin of China's first space station, the core module of Tianhe is about 16.6 meters long with a diameter of over 4 meters. It's divided into 3 parts: the connector, the life support and the control section, as well as the section for resources. The connector looks like a hexagon. It has 2 berth ports for 2 lab modules called Wentian and Mengtian, and 3 docking ports for the Shenzhou crew spacecraft, the cargo and other vehicles. It also has an exit on top where astronauts can conduct spacewalks. This is the living area of the crew. It's about 50 cubic meters. It's also called the thinner area. It's got 3 sleeping areas and 1 sanitary part. This is the thicker part, which is the working area, where astronauts control the daily operation of Space Center while conducting some scientific experiments. If we take a look from the outside, this is the resources part of Tianhe. It's responsible for fueling the space station. Once operational, the space station can host 3 astronauts for 6 months and up to 6 astronauts by replacement. Tianhe, along with its Long March 5B Y2 carrier rocket, has currently been transported to China's Wenchang spacecraft launch site in Hainan province, and it's all set to kick off its journey into space. Yo Yang, CGTN, Beijing.
And for those of you who are joining us just now, you're now watching our special coverage of China launching the core module of its space station. That was a shot of the command center showing you the humidity, the weather of today. And this is a great view of the rocket we're launching today. The rocket was especially developed to launch the space station modules for China. And today it's about to launch the 22-ton Tianhe space station core module into the space, and we call it the Chubby 5 or Pangwu in Chinese because of its size. It's a heavy lift launch vehicle.
I like that nickname.
In our field, it is called the aspect ratio, which means the length and the diameter, this ratio. Long March 5 has a diameter of 5 meters, so the aspect ratio is not very high. So this means that it is more rigid than other vehicles, and also for this design, it brings some convenience of the flight.
And looking from here, it might not sit that big to you, but just give you a sense of how big this is. The Long March 5B is about 53.7 meter long with a, like Professor Yang just mentioned, 5-meter diameter core stage, and also 4 strap-on boosters, as you can see now at the bottom of your screen. Those are the side boosters. The diameter of that side booster alone is about 3.35 meters, right? That is as big as a normal rocket, such as the Long March 2F or Long March 7 rocket, which is pretty impressive.
Yes. As Mr. Xu has mentioned, because of the limitation of the railway tunnels, so our inland launch site can only use the diameter of the 3.35. So that is the diameter of even the core stages of other rocket vehicles. But for this launch vehicle, the boosters has so big diameter. And we should also emphasize that the 4 boosters provide more than 90% of the thrust, of the total thrust during the liftoff. Because they use a powerful rocket engine called YF-100, which have a thrust of about 120 tons. So each rocket boosters use 2 of these engines. So totally, the 4 boosters can provide a thrust about 960 tons. You can see that this is the biggest launch complex in China, and just now we can see from the camera that there are some white fogs coming out from the top of the boosters. That is the oxygen. That is vaporized liquid oxygen, because you know that it must be kept in a very low temperature, and by vaporizing.
All right, that is the call out you're hearing now. It is 30 minutes prior to launch. It is T-minus 30 minutes. And at this point, what happens here, Professor Yang?
Well, we have a countdown in different stages. For the 30 minutes countdown, we've already completed many checking of the critical systems. For instance, such as the telemetry and the tracking systems, the space tracking ships, and also to confirm that other systems are okay. Moreover, we should also test some of the subsystems on board the vehicle itself. So each must be kept in good condition and monitored by the data downloaded. And also, you can see also there are some small arms on the vehicle, because we have multiple plugs connected to the vehicle, and one by one they will be disconnected, and finally the major plug, the main plug, will be disconnected, and the vehicle will be completely depending on the power supply of itself. At that moment, we can perform the launch.
And it is also the time where, you know, the last batch of team members pulling away from the launch pad, is it?
So at this moment, there is no ground staff near the vehicle, because it will be very dangerous. So there are procedures, or the safety procedures ensure the safety of our staff. You see that the fueling has been completed several hours before. At this moment, the ground staff must leave the launch pad, because if there any uncertain things happened, the explosion will stress the life of our ground staff.
And the umbilicals we're looking at, they are still attached to this rocket. Why is it?
Because we still need connections, some cable connection to the vehicle, such as the power supply, such as a monitor of the signal and the control commands to the vehicle. So until the last minutes, maybe 1 minute or just several seconds before the launch, finally we disconnect the main plug.
What are those cable and it seems a lot of the pumping tubes there, so connecting the main body of the rocket and the service structure. They have been pumping I think it's the fuel, right? It's just, they need to keep fueling that rocket until the last minute.
Yes, you see that we need storage batteries to provide electricity during the flight and before the launch, just after the disconnection. So we must save the energy of the storage storage batteries because the capacity is limited. So just at this moment, still there are cables connected to the vehicle to provide power supply.
Yeah, that is the cost that we have to pay for making the more environmental friendly engines and the more environmental friendly fuels, right?
That's true.
Yes.
And the timing of the launch, Professor Yang, talk to us a little bit about it. How did they choose this launch window? I would imagine a lot of factors went into this decision.
Yeah.
Well, you see that because this is the first launch of our Tiangong space station. Theoretically speaking, it only need to launch into orbit with the right attitude and the right inclination. So theoretically speaking, there is no much limitation to this, but also there are some limitations about the sunlight. You see that when the Tianhe module come into the orbit, the sunlight must in the right direction to ensure the power supply of the vehicle. So the launch window is limited by this consideration. The angle between the direction of the sunlight and the orbital plane must be less than 30 degrees. And also this because this is a condition of the sunlight, and also the time of the launch, we must ensure that when the rocket, the end stage of the rocket is separated from the space station, when the solar panels is deployed, there are also sunlight to ensure the power supply.
Yeah, so sometimes we saw this kind of launching window in the middle of the night,
Yeah. But this is the launch of the first module. For the second module and other ships, the things will be changed because they must launch into the first orbital plane. The accuracy of the launch window is only 1 second, which is called zero launch window.
Zero launch window.
So once it's missed it, you have to be...
Another day.
Oh,
they have to totally reschedule then.
Well, it's maybe better than the Mars exploration because once it's missed, it's going to need to wait another 26 months, right?
Maybe the next, for this, maybe the next 24 hours. Every day we have a launch window for this, for the next vehicle to go into the same orbital plane of the station.
And Mr. Xu, let me bring you into our discussion. We are looking at the view of the command center at the Wenchang Spacecraft Launch Center. And talk to us about this launch site. I mean, there are 4 major launch sites in China, right? This is a great coastal view. I mean, this satellite launch center or launch center is located in coastal regions, but we already have another one called Jiuquan Satellite Launch Center. That was way up north in the Gobi Desert, right? That one is for launching astronauts into space, while this one you're looking at is responsible for launching cargo spacecraft into space. Why is that, Mr. Xu?
Well, I think this is like previous, we have just mentioned about the fueling system. We have developed a new generation launch vehicle, which is based on liquid kerosene and oxygen. That fueling system is part of the infrastructure of the launch site. So the Wenchang satellite launch site is only for kerosene, oxygen, and hydrogen fuels. There is no other fuel system that is available for the rocket in Wenchang. So new generations starting from Long March 5 onward, such as 6, Long March 7, and 8, will all use the same fueling system. So all of those rockets you will see in the future will be launched from this particular launching site, including the Long March 7, which is due to be launched very soon following this mission of Long March 5. As you mentioned about Jiuquan, I think we also need to mention about the system engineering of such a complex program as human missions. The system comprises not only the launch vehicle, but also the TT&C support system, the ground facility, the manufacturing, the operation, and the human missions, including life support system. All of this will be put together and to form a complex and very complicated system. So as you can see, at the launching site, they're preparing for the launch of the Tianhe, and also busy at Jiuquan, they're busy with the astronauts preparation. So once the Tianhe is in orbit, in the right inclinations and orbit, as Professor Yang mentioned, once in a day opportunity. So once we capture that window and we insert this Tianhe into the right orbit, and we will start preparing for the following missions. And of course, the designing of the orbit as well as the launching opportunity is also based largely on the orbit and communication capabilities. It has to be flying over the Chinese territory that we are able to see and witness, to control the rendezvous docking in the future for the human missions.
Mr. Xu, the Long March 5B is going to launch from the Wenchang, and how long can we expect it for this flight? Like, how long did it take to enter this orbit?
Roughly, we consider that launching opportunity, timing by seconds. I think it's around 1,270 some seconds before we see the insertion.
That's about 10 minutes.
Yes. So once it's in there, they will see the deployment of the solar array of the Tianhe and then start communicating with the Tianhe. So right now, the ground crews as well as those connecting ports or the umbilicals you can see from the ground to the launch vehicle is basically communicating with the launch vehicle as well as communicating with the Tianhe station. So once it's launched, we'll focus on the control of the launch vehicle, and once deployed, we'll communicate with the Tianhe directly with using TT&C network, that including the ocean-going ships as well as the ground crew. So it's a process that will take very close connections between each other.
And let's talk a little bit about the Tianhe core module, right? Because she is the star today.
Yes.
You were looking at the bottom of the rocket, but at the tip of that rocket, the Tianhe core module was actually encased in that huge casing called rocket fairing, right? And Dr. Yang, talk to us about it. China hopes to have its first space station operation by 2022. But how is this core module instrumental to the space station's construction?
Well, of course, the core module will be the most critical step of the construction of our station. In fact, this Tianhe 1, the accurate name is the test core module. So at this moment, it is not the formal core module of the station. So after launch, we will perform many critical or key technology demonstration as testing. If all these are okay, we can formally change the name to the core module. If something wrong, we must have some improvement. We will launch a second core module. That will be the formal one. So before this, we must perform the demonstration of many key technologies. For instance, the long-term residence of astronauts in space, the regenerative life support system, and also other technologies to operate so heavy spacecraft like this. And also, we need to test the transpositioning technologies for the experimental modules. You see, we choose a different technology comparing with other countries. Although we also choose a modular design like the Mir station and the International Space Station, but when the Mengtian and Wentian modules is docked, we transfer its position by a special mechanism. So we must test this technology.
Well, thank you, gentlemen. Stay with us. And China is set to have its own space station orbiting the Earth by the end of 2022. So how many missions is this going to take to get everything up and running and keep it that way? CGTN's Wule explains.
It took me only a few minutes to finish this model of the Chinese space station. But if you're going to build an actual one in space, it's not that simple. China's Tiangong space station project consists of 3 stages: key technical verification, construction, and operation. The successful maiden launch of China's Long March 5B rocket in May of 2020 was a key milestone, validating this rocket as a viable vehicle to lift the station's core module called Tianhe into its designated orbit. Tiangong will be a T-shaped structure with the Tianhe core module and Mengtian and Wentian experimental modules. Besides the 3 launches to put the modules in orbit, China has planned 4 manned missions and 4 cargo missions. 11 intensive launches in total by the end of 2022. All of China's manned space missions will rely on this Long March 2F rocket. The Shenzhou spacecraft sits on the top of the rocket. Once the core module and later the entire Tiangong station are in place, this specific craft will dock with the core module while in orbit. Chinese astronauts will not only conduct a number of experiments, but also carry out extravehicular activities to help complete the construction of the space station. Living and working in space for long periods of time requires more supplies. This is where the Long March 7 carrier rocket comes in. It will be used to carry the Tianzhou cargo ship, which will contain food, water, and other necessary supplies to the space station. All of these missions are integral parts, furthering China's endeavors for space exploration. Wu Lei, CGTN.
And welcome back. You're now watching our special coverage of China's latest special launch. We're just 16 minutes away from that launch, and staying with us are our guests, Mr. Xu Yanzong and Dr. Yang Yuguang. So, Dr. Yang, let's start with you this time. To construct such a space station is planned as the last step of China's manned space program that was envisioned firstly in 1992, right? 29 years in the making. I mean, how have previous steps contributed to this moment?
Well, you see, there are three fundamental technologies needed for construction of a space station. The first one is the transportation, the crewed transportation from the Earth to the outer space and back. This is the first technology. The second is, as Wu Lei has mentioned, the EVA or extravehicular activity technologies, which we accomplished by the Shenzhou 7 mission in 2008. And the third technology is rendezvous and docking technologies, which we completed testing by the Tiangong 1 target vehicle and the Shenzhou 8, 9, and 10 spaceships. Also with the Tiangong 2 and Shenzhou 11 Tianzhou 1 mission, we mastered the technology of midterm residence in space by Mr. Jing Haipeng and Mr. Chen Dong. They stayed there for a month. And also with the Tianzhou 1 cargo ship, we mastered the technology of refueling, which is also critical for the future space station. So with these preparation works, we master most of the major technologies of constructing a space station, but not all the technologies. So we still need the demonstration of technologies during this Tianhe 1 and the Tianzhou 2, Shenzhou 12 mission.
All right, 15 minutes to go till the launch.
That's right.
All right, you hit the
the controller's saying that is the 15 minutes countdown. And Mr. Yang, well, yeah, this is the whole plan has been carried out step by step, according to you. Doug, Mr. Xu, I want to ask you that what did we learn from those previous missions, like Tiangong 1, Tiangong 2, and Shenzhou spacecraft?
Well, the Tiangong 1, we learned something very special. Let's talk about Tiangong 2 first.
Yeah.
Rendezvous docking, as well as the connection between the cargo ship, there are two ways. Automatic or automated docking and rendezvous, and man-controlled rendezvous and docking. So we have demonstrated all that, and also we demonstrated the fueling of the station in microgravity environment. This is crucial because now once you're in microgravity environment, the fuels are floating instead of just dropping on the bottom of the container. So the fueling can be very challenging. And also requires special technologies.
And Dr. Yang, you were watching the live feed with us. What was disconnected just then?
Well, that is a cable which monitoring some of the subsystems, some critical systems of the vehicle. You see that we have a control system called the GNC or guidance, navigation and control system. We must keep that for instance, such as the gyroscopes, the accelerometers, and the onboard computers are okay. So we have the cables to have data links that download the critical parameters of these instruments. And before the launch, you see that there are several cables. So just now we just disconnected one of them. There are also other cables. Just before the launch, we will disconnect the last one, which provide also power supply to the vehicle. And now, because some of this system have already been okay, we also hear from the front, from the ground control center, there are the Tongguling, which have a ground tracking station, is also okay.
All right, about 10 minutes into the final preparations.
Yeah, with those, the cables that's been plugged in, this the main body of the rocket, we're still, we can still manipulate that rocket through those cables,
we
right?
can still send the commands to the vehicle.
Yeah.
And also we can get data, the monitoring of the all systems of the vehicle from these cables.
Right.
So also the most important, the power supply to the vehicle. As I mentioned, because the storage battery only have a limited capacity.
But after the cutoff of those cables, the rocket is on its own.
Exactly. So just several seconds before the launch, the onboard computer will control all the critical system of the vehicle.
And Mr. Xu, we were looking at the launch team in our screen now. Talk to us, what is it like for them? I mean, during these last few minutes, few seconds leading up to time zero. I mean, it is one of those heart-pounding moments, I would imagine, right? It's got to be extremely nerve-wracking, but at the same time, you got to keep calm and focus on what you do. What do you think is going through their minds?
Well, as we started from 30 minutes countdown to all this moment, there's a sequence that I've already designed many times, and so they have also practiced all of this many times. So I think their lack of they're good in confidence because the data, as Professor Yang mentioned, are constantly feeding back from the rocket. Even though the cables are disconnected, we still have remote TTNC signals, and we have also all the sensors that is working. So the ground crew or in the command room, they're controlling, monitoring, and keep constant eye on those signals, on those sensors, on the data, some parameters. So if everything goes normal, because they have the chart to compare, and if everything goes normal, they will go to countdown to the last minute or the last second. If not, they will have the authority to call off the launch. We have this happen before, even seconds before the launch, we call off the launch itself because of the anomaly occurred in the launch vehicle. So even disconnected, we still have all the connections made to the launch vehicle.
Mr. Xu, in a previous we mentioned that the carry out by the NASA, we can saw them from the live streaming that there is the go no go procedure. It's a poll to decide
polling,
whether they're going to give a call to go, right? Are we going to have the same procedure here in China?
Exactly.
Yes, we do, and
all right, later, Mr. Yang.
Many similarities, and also we have our own system of calling off the launch.
All right, 10 minutes out. 10 minutes out. This is the final status check. We are going to hear. Oh, that's the call out from the commander.
We can hear from the ground control center that the chief commander has announced this T-minus 10 minutes countdown.
And what happened prior to this, around this time, is that the air conditioning for the fairing has been cut off, right? Talk to us about it.
You see that the temperature and other environmental parameters must be kept in the correct range during the launch. So there is an air conditioner inside the payload fairing. It also needs the power supply. Just before the launch, because only 10 minutes, we can ensure that even if it is shut down, the temperature is still in the right range. So at this moment, we can shut down the air conditioner and go on. And as Yan Song has mentioned, we not only have signals from the cables, we also have wireless connections. You see that the payload fairing is made of metals. So we must prepare some special non-metal material to have a window to allow the radio signals to coming through.
That's right. That's a most comfortable zone within that fairing.
And the Tianhe core module includes the living quarters for astronauts and control center, right? It needs to provide life support for astronauts, so air, water. I mean, how is that being met, Dr. Yang?
Well, you see that from the outside, we can see that the core module is composed of a node, a small cylindrical segment, and a large cylindrical segment. The bedroom or the sleeping chamber of the 3 astronauts is in the small cylindrical segment. Okay. Also, there is a toilet there.
They gotta have that. Gotta have that.
Yeah, Mr. Xu, can we go ahead with our go no go question? I'm still very curious about that. We have been interrupted by the countdown.
Well, yes, I think the go and no-go is basically on the launch vehicle statics. We see the pressure of the engines, and all the engines are okay, and all the ground control and systems are fine. Because once you have the liftoff, you have the rocket only controlled by the TT&C system, and all the data has to be transmitted back. So we have to make sure that all the sensors in different part of the rocket, in particular the engine system, the fueling system, and the all of that has to be in the right temperature and right pressure. This happened before because we've seen anomalies of one of the sensors that could be affected not only by the rocket itself but also by surrounding environment. As you know, the Hainan is a highly humid and high temperature areas. So that also happened in before for the liquid kerosene or oxygen engine. So all of the factors are compiled together. Some of them are critical enough to call off the launch. So, but fingers crossed. Certainly, we hope this one is a smooth one.
All right, that was a great split screen, but you're now watching at the side boosters of the rocket. We are just moments away from that liftoff. Also talk to us, Dr. Yang, the energy about the core module. I mean, everything run in the module needs energy, right? And I suppose solar energy is the main source?
Yes, you see that's the final step of the launch, in which case we can announce the successful launch success of this mission will be the deployment or the unfolding of the solar panels. That means the core module can have continuous power supplies from the sun. You see that our core module have one-dimensional SADA, or the solar array driving assembly, which can rotate and let the surface of the solar panels meet the sun.
All right. And they do have Wi-Fi up there, I heard. Is it true
Exactly.
that they're going to have 5G
Yes.
coverage?
Yeah, they can
Yes.
play the video games and talk to their family.
Maybe they can play a video game, but maybe the astronauts should bring a laptop to the station. So you see that this happened during the operation of the International Space Station. But you see that's the most favorite entertainment of the astronauts is not video game. It's just watching the beautiful Earth and taking photos of them, of their family, of their cities, and other countries.
That is great. Right. And the core module, eventually the space station will be flying in low Earth orbit, right, Dr. Yang?
Yeah.
And it's going to be affected somehow by gravity. So once in a while, it needs to readjust its position, and that needs refuel. How is refueling going to be achieved?
Well, you see that we adopt docking mechanism called the APAS, or the endogenous 5 minutes countdown.
5 minutes countdown. We are entering the final stages, really. Oh, there you see Chinese Premier Li Keqiang. That is the live picture coming out from the Beijing Aerospace City. Chinese Premier Li Keqiang is among the audience who are watching this launch very closely. That is Mr. Wang Huning, member of the Standing Committee of the CPC Political Bureau. They are there to watch this, which really speaks volume about how important Beijing sees this mission, isn't it, Dr. Yang?
In every important missions, our Beijing Flight Control Center also taking a very important role to give commands. So you see, there are control centers in Beijing and also in the front, actually speaking in Wenchang, which controls the rocket itself. But also we have control centers in Xi'an to control the TT&C system.
Okay.
And Chinese leaders are showing up in this control center. It's another symbol to show how important today's launch is.
And very interesting, that Beijing Aerospace City you were seeing is also the main training base for China's astronauts, right? A lot of Meet the Press events were actually held there.
Yeah.
It's just in the northern part of Beijing City, right?
And the primary function of that Aerospace City is also known. All right, this is the live picture coming out from Wenchang. That is Mr. Zhang Youxia, who is in charge of this mission.
The chief commander of China's manned space program, no.
Right.
And today's launch is going to kick off the series of launching and coming, I think it's in 2 years, right?
Yes.
There's about 10 more launches except for today.
11 launches.
11 more
total.
launches.
11
including
launches
this
in
one.
total.
And this launch is going to be followed by a manned mission
No,
very soon.
the second one will be the launch of, as Willie has mentioned, the Tianzhou 2 cargo ship, which will be
But that manned
launched
mission is
also
going to
in
be
this
in
Wenchang. The cruise mission will be the third one.
All right, that is
So call off
T
again.
minus 3 minutes. We're here in the call out, 3 minutes out, less than 3 minutes prior to liftoff. They are going through some final status check, I would assume. And quite a nerve-wracking moment, I
Right,
mean, for
it's,
the whole launch team and for all of us who are watching.
Yeah, it's approaching us. I'm getting excited
Yeah, a
to see
gazillion
that.
things
Right.
must be going on, and everything needs to be done right in an orderly fashion. Any tiny mistakes
Right. I wanna
that could be catastrophic.
I want to get back to the very fundamental question for both of you, Mr. Yan and Mr. Chu. What is the significance of the construction of a China space station? Why do we need a space station?
Because this is one important step for us to be an advanced country in space field. We've already been a big country. We hope we can be. This will be a very important milestone for us. And also, it is not only the national laboratory in space, but also a very important international cooperation platform.
Well, I think it's also very important for our future human missions, either to the moon or beyond. So if we want to be an interplanetary species, this is the very first step.
Did we see the umbilicals pulling away? Is this about the time that the umbilicals
Maybe several
pulling away?
seconds later.
Several seconds later.
Second is the final plug or the major, the main plug will be disconnected.
And that will indicate that the launch pad team has given a go.
And just
to the
before
launch.
this disconnection, the power supply will change from the ground to the vehicle itself using the storage batteries.
2 minutes, I think it's
2
2
minutes out.
Yeah, I heard that. It's 2 minutes. Yeah, we're watching this
There
Long
also
March 5B. I think that's for 335-meter diameter boosters.
Yeah.
Tell us more about that booster.
the booster, as you mentioned, the booster has a diameter of 3.35 meters using liquid oxygen and kerosene as the propellants,
okay.
and each have a thrust of.
Oh, I thought it was
two,
a solid. I used to thought it was
No,
solid.
it's not solid. It's
not
liquid,
solid.
liquid
So
rockets.
liquid fuels.
And
All right.
So that was using the liquid oxygen, right?
the
fuel?
core stage use liquid oxygen.
Okay,
Yeah.
we're seeing the countdown clock there.
Yeah. So everybody's watching that. So.
All right, T minus 60 seconds, 1 minute prior to liftoff. Truly an incredible moment to witness.
Well, I'm getting nervous right now.
Yeah.
There are also cameras on the rotational arms to monitor the disconnection of the plugs.
And
All right.
ladies and gentlemen, if you're just joining us, you're watching the live feed coming out from the Wenchang Spacecraft Launch Center. China is about to launch the core module of its Tiangong space station 40 seconds out. The Tianhe core module is on board that rocket you're looking at, the most powerful heavy lift rocket, the Long March 5B rocket, 30 seconds out. 29 years after China's manned space program was envisioned, the first module of the space station is finally being launched to space. Less than 20 seconds out. What an extraordinary moment. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition.
All right, lift off.
And liftoff. What an incredible view. That is the sound of history. A historic space flight carrying the Tianhe module, the core module of China's space station. That itself is history in the making, a major milestone of China's space program with the ambition to explore deep space. Not even gravity contains humanity now. And Dr. Yang, we are looking at the view of the side boosters, aren't we?
Exactly.
Yeah.
This is a camera mounted on the core stage. You can see it's looking downward. We can see that's the two of the four boosters.
So
and
we
also
are
the flames.
looking down at the tail of the rocket, right?
How did they install that camera on that?
This is a very small camera mounted on the surface of the core module. So it does not influence the shape, the total shape of the vehicle. And also don't have the aerodynamic influence.
And keep in mind the Long March 5B has 4 strap-on boosters like this. You are looking at 2 out of the 4, and they run on liquid fuels. And in the next few minutes, these boosters will detach and fall away after propellant is burned up. All right, 69 seconds into the flight, everything looks to be going good. The core stage will continue to burn after these boosters detach. And in the next few minutes, we're going to see some major steps, are we, Mr. Xu?
Look.
Yes, I think the separation of the booster will be the first thing you will see, even visible with your naked eye. So the strap-on booster provided more than 90% of the propulsion as of this moment. So once it's in the outer atmosphere, about 100 kilometers off the ground, you'll see the fairing also will be separated and deployed.
And we're seeing this 3D animation on the right of your screen, right? And you can see the rocket has pitched over a bit. Originally, the rocket is shooting up vertically, but eventually it will fly in orbit, so it's going to take a turn in direction.
They're rotating and turning slightly, and now it's heading to the orbit.
Southeastward.
Okay.
And you can see that bright orange flame out of the nozzle.
Yeah, it started with the vertical flying, and then it will turn.
So the pitch over is the first operation after liftoff is already being successfully completed. And as Yan Song has mentioned, the next step will be the separation of the 4 boosters just 3 minutes after the liftoff.
All right, that's the major event coming up, booster separation. Why is this critical to this flight, Dr. Yang?
Because separation is always very dangerous. There are influence of the aerodynamic forces, and also the separation itself has some shock and vibration to the instruments.
And speaking of that, when are we going to hit maximum Q, max Q, and when is the rocket supersonic?
Yes, actually speaking, at this moment is already supersonic.
Right. That is the engine shut off, booster separation.
Great.
You can hear the cheering and applause from Command Center. Looks like we've got a good separation.
We've got a good start.
Separation.
It's a good start.
All right.
So you can see, it's just the core stage, it's flying.
So you can see also this is
the
camera. Oh, this is inside the payload fairing.
Okay, so next up is payload fairing separation. Okay,
that is the core module that we're watching at.
We can see there are some lights inside the payload fairing. And also, you see on the right of the window, the screen is the 3D animation. This 3D animation is based on the real date downloaded from the vehicle, the position, the attitude, and the condition of the engines.
So that was actually based on
great.
Great fairing jettison. Another round of applause.
It's ejected.
Good separation again. And you are watching at the dotted yellow lines, right? What are they? These are data links from ground tracking
that shows
stations,
in which station is connected to the vehicle, either uplink or downlink. So you see, we have stations in our Xisha Islands, and also we have the space tracking ships in the Pacific Ocean.
And now the Tianhe core module is actually exposed in space, right? Is that what we're looking at the left side of the screen?
Yes,
after the fairing jettison.
So this is the camera mounted also on the core stage and looking forward, not like the last camera we mentioned. So you can see part of the space station.
Mr. Xu, it's very interesting to see that because the Long March 5B is the single stage rocket. It's not like the Long March 5, and in the previous mission, we can saw this the rocket is just to throw away the stage 1 and stage 2, and just to have a very smaller parts to enter that space and enter that orbit. But in this case, the Long March 5B, there's going to be a huge core stage flying in the outer space.
Yes, it's going to be a single burn. I think once you have the separation of the strap-on booster by the pyrotechnics, we also have the separation of the fairing. So now it's flying right into the direction and the altitude it requires. So once the engine shut down, it will have a small adjustment to the appropriate inclinations and orbit, and it will be a separation of the core stage with the Tianhe. So once that is happened, it means the success of this mission, of this launching phase.
And I think it's going to be more complicated than the multiple stage rocket, because You got a bigger stage. You got a main engine that to create is 140 tons of thrust, and you stop them suddenly. It's like I think it's like the high-speed train have an emergency stop. Can they just get into this orbit properly?
You just mentioned a very important fact. Because you see that Long March 5B is the only rocket in the world that only have a 1.5 stage to come into orbit. So there are many great challenges. For instance, as you mentioned, we use the two YF-77 rocket engines in this core stage, which have a thrust of 50 tons. That means that the total thrust of the core stage is 100 tons. It's very big for when it is shut down to come into the orbit, because you see that we have very strict requirement in the accuracy of the orbit. Well, for this accuracy, the smaller the thrust is, it will be easier. But you see that the thrust is rather big. And at this moment of the shutdown, the core stage, the tank is almost empty. So it is very difficult for us to keep the accuracy. That is a great challenge when we developing this Long March 5B launch vehicle.
That is really an extraordinary view. I think that's the Earth on the left side we're seeing, right? That bright light you're watching now. And the rocket is flying over the Pacific Ocean, right? It's actually flying eastward.
Southeastward.
Southeastward. So it's
because the inclination of the orbit will be 41 to 42 degrees, while the latitude of the Wenchang Satellite Launch Center is 19 degrees. So we need the direction we call the launch azimuth. Launch azimuth is going to the southeastwards.
450 seconds into the flight.
Mr. Xu, I think we're expected to see the next stage, probably to cut off the main engine. Am I right?
Yes, shutdown of the main engine and the separation. So, but once we reach that altitude and velocity, we will have that happen. So this liquid kerosene and liquid hydrogen oxygen engine will continue to burn, and it will have a very high efficiency once in outer space, unlike in atmosphere. So the advantage of hydrogen and oxygen engine will be fully displayed in outer space.
Did we heard the engine cut off?
The engine has been cut off.
Spacecraft separation.
Great.
Separation is ongoing, and
a perfect view. This is the
video from
core
the
module
end stage.
Right.
This is a video from the core stage of Long March 5B. Yes. And you can see from the screen on the left side is the Earth, so bright because it is under the sunshine.
Wow.
Wow, a good spacecraft separation. Tianhe core module now is flying by itself in orbit.
Way to go.
It's already in the initial orbit. Theoretically speaking, the perigee should be about 170 kilometers, and the apogee should be about nearly 400 kilometers.
Wow, you can see quite a relief for the launch team.
That. It's a very excited day.
They have worked years and years on it. I've seen some interview from the Launchpad team. They're saying that it feels like this Tianhe core module is like their child. So this launch feels like really sending off your child. They are excited for it, but they are, they feel kind of sad. It's a mixed feeling, sad to let go.
They spent decades on working for that.
So you can see the 3D.
How long have they started this project?
You mean the whole manned space program?
Yeah, this.
We just started the manned space program since 1992. It is called 921 project. So because of this data, you can see from the 3D animation, now the vehicle, the station is on itself. The Long March 5B has already completed its task. And the station must first stable itself, because the separation may brought some disturbance or perturbation to the attitude of the vehicle. So it must use its rocket engine to make it stable. And then will be the deployment of the large-sized antenna, because you see that there are high-speed transmissions of signals to the data relay satellite. We must deploy the antenna first, and then will be the unfolding of the solar panels.
And that's going to happen in about 50 minutes time?
Yes.
That is Earth. That's a great view.
That's Earth. Wow.
So what are we, still talk to us about what are we expected to see. You talked about antenna deployment. Why is that taking so long to deploy this?
You see that before this, as I mentioned, we must keep the station stable. Usually the rocket itself, the separation is very slight, but they still have some disturbance, maybe several degrees per second. So after separation, the propulsion system of the station will start and use the small engines to reduce the angular velocity to a very low level. So at this moment, we can call that we have set up the attitude of the vehicle. And then we'll check some critical subsystem, for instance, such as the TTNC, such as the power supply and other critical system. And then will be the deployment, as I mentioned, the antenna. This is the preparation for the future to set up a high-speed data link between the station and the data relay satellite.
Mr. Xu, I think we're watching this Tianhe core module is entering the orbit, which is at the altitude of 400 kilometers above our head. Tell us more about this orbit.
Well, I just noticed a little bit of the tumbling of the station at the separation. So the small adjustment is very much important to readjust the orientation of the Tianhe station before deployment of the solar array. The separation seems to be, a little bit disturbed, or some effects on the attitude of the Tianhe. So I'm sure that the ground crew are busy controlling the Tianhe station to the right altitude and the right directions, using the small propulsions that is for orbit adjustment. And then we will have the right angle to deploy the solar array. And then once that is done, we will establish a long-term communication with the ground, and the TTNC crew will have a good communication with the module. So that will be unlocking of the stations and preparation for docking with the cargo ship. The cargo ship is very important for fueling the station, because we don't have too much fuel on board the Tianhe segment. So we need the cargo ship to go ahead to supply the fuel and docking with the fueling before we have the crew on board.
So we're going to have some adjustment burns, and you are looking at a replay of the moment of liftoff. A magnificent view, truly. And normally, launch providers and launch agencies, they would have a simulation like what we just saw, the 3D animation that takes in all of the live data, that does a visual representation of it. That was not a pre-made program, not a pre-made video, but it shows you what is going on in real time, and that'll even show you when they're as an anomaly, right, Dr. Yang?
As I mentioned, the 3D animation is based on the data get from the real flight, the position, the velocity, the attitude, and the status of which engines are working. So we can get the real status from the screen.
That's right. And the Tianhe is going to pick up this orbit at about 400 kilometers above our head, and that's the same. I think it's the International Space Station also using that orbit. Why they just why they just fly that low, Dr. Yang?
You see, that's most space stations and manned space activities in low orbit are in several hundred kilometers, usually no higher than 600 kilometers high. This is because you see that outside the Earth there is a radial belt called the Van Allen radiation belt. The bottom of this radiation belt is about 600 or 700 kilometers. So if our spacecraft is higher than this altitude, the astronauts will be influenced by the radiation. So that's not good for the health of the astronauts. On the other hand, if the orbit is too low, for instance, less than 300 kilometers, the aerodynamic drag will greatly influence the orbit. We will need more propellants to keep the orbit of the spacecraft. So it should not be so high and not should be so low. So in the years before, our Shenzhou spaceship and our Tiangong laboratory usually in the operation orbit about 350 kilometers high. And for this station and the International Space Station, they can work in the altitude about 400 kilometers.
As we speak, the Tianhe core module is flying in orbit now. 16 minutes into the flight, everything continues to look good. We went through several key separation status, right? Where do the boosters go? Where do the fairing go? And where do the first stage land, Mr. Xu?
Well, there are drop zones in the Pacific. We normally design the vehicle in such a fashion that the the dropping of the what we call expendable launch vehicle parts are not affecting the normal life of people. So those drop zones will be in deep oceans in the Pacific. So the first 4 strap-on boosters will be dropped near the Saipan areas, and then the fairings will be dropped subsequently in the southern Pacific in areas that is not habited by people. So this is also the purpose of the Hainan launch site, so that we affect the people's life.
So as you said, this is an expandable rocket, but I understand that China has experimented actually on reusable rocket, right? Tell us about that. When is that going to be applied to?
We're doing a lot of experiments on the reusable launch vehicles. We have also seen the international effort in particular SpaceX can bring the rockets back and also even recycle the fairing. We're looking at the possibilities because there are special technologies involved in the reusable of rocket engines. Some of the engines are once you have the materials you use are for single time only, but the technologies as SpaceX using the Mullins engine, which has been demonstrated on the space shuttle, and the technology has been transferred from NASA to SpaceX. So there are many factors affecting the reuse of engines, the reliabilities as well as the cost-effective factors, whether we use the reusable or we use single expendable, because the reusable technology also requires you to put on more fuels and to bring the rockets back.
All right, Dr. Xu, Dr. Yang, thank you for your analysis, but don't go away. We're going to come back to you in just a bit. And you're now watching our special coverage of China's space exploration. A Long March 5B rocket has just launched Tianhe core module into space from Wenchang spacecraft launch site in Hainan province. And let's now go to our reporter, Ning Hong, who is live at the site. Good to see you there, Ning Hong. So what's it like for you? Describe what is around you. It's actually Tianyuan here, Ning Hong.
Well, the rocket had just lifted off a few minutes ago and successfully sending the core module of China's space station into orbit. And this is a very unique event because, well, this is China's first space station. Although the core module weighs about 22 tons. And the rocket, the Long March 5B, is specially designed and built to send spacecrafts as large as this into low Earth orbit, 22 tons, I mean. And the rocket has successfully complete its mission, sending the module into the orbit just a minute ago. And I heard people are cheering as the core stage separated with the core module, and because this marks that the rocket has successfully completed its mission. And now what we're waiting now is that the core module has a new solar panel. It's called a flexible solar panel. It will extend from the core module, but it will take more time, much longer than what we have before, because the core module has a really high demand on energy. So this new panel will certainly bring more energy to this core module, and as well as astronauts that will be working inside it. So now we're still waiting for the confirmation about this. And once the solar panel extended, this mission will complete. So we're still waiting for this information.
All right, quite an exhilarating moment. We're truly witnessing history to be made here. Thanks so much, Ning Hong, joining us live at the launch site.
And you're watching our special coverage of Tianhe core module's mission to...
and we're going to take a short break.
That's
and
right.
Don't go away. Stay with us.
Each day, there are millions of stories. Each one can open new perspectives, new possibilities. Wherever you look, we are there to see, discover, explore. We put the pieces together to find what really matters to you, all around the world, all around the clock. Our reporters are at home across the globe. From our headquarters in Beijing and production centers in Washington, Nairobi, and London, China Global Television Network. Stories from across the globe, reaching people across the globe. CGTN, See the difference. Find new opportunities. Discover a path forward. CGTN. See the difference.
Welcome back to our special coverage on the biggest space news here in China.
Yes, a Long March 5B rocket has lifted off Tianhe core module into space. And from Wenchang Satellite Launch Center in South China's Hainan province, Tianhe is the foundation elements of China's planned orbital space station, which will be joined by another 2 experiment capsules to make up the whole station by the end of next year. And China has another 10 major space missions to be launched by then, as it aims to complete the construction of its own space station.
That's right. A space station is a giant orbiting lab in the outer space of the Earth. And currently, there is only one international space station which China has no access to, having been barred involvement by the U.S. Congress over issues of, quote, national security. And besides this reason, why China is building its own space station? CGTN's Wu Lei explains.
Here on Earth, an apple will fall due to gravity's influence. But in outer space, it floats like this. But how might this apple mutate in a microgravity environment? What might happen when an astronaut eats this apple? China has sent 11 astronauts into space since 2003. During their time in space, the astronauts had carried out a variety of experiments. But their time for each visit was limited. China is aiming to remedy this by building a brand new space station by the end of 2022, which is expected to remain in space for over 10 years, allowing astronauts who spend time there to engage in longer physical, biological, and cosmological experiments. As for experiments, Chinese scientists are interested in growing plants. These flowers and vegetables were growing from seeds mutated in space. The effects of living in space are also of concern for scientists. Knowing how to guarantee the ability for astronauts to have a healthy long-term stay in space could pave the way for future space travel. China's new space station won't just be for Chinese scientists, but also for global scientists as well. So far, a total of 9 projects proposed by 17 countries, including Germany, France, and Italy, have been selected for the first round of experiments to be conducted in this new space lab. This new facility is expected to open up a brand new chapter in human space exploration. Wu Lei, CGTN.
Well, let's take a look now at some of the experiments that are expected to be conducted on the new space station in China. There are 9 projects from 17 countries that stand out from the 42 applicants since the announcement of opportunity in May 2018.
2 related to astronomy, a gamma ray experiment involving Switzerland, Poland, Germany, and China, and a nebula gas experiment by India and Russia. 3 related to microgravity fluid physics and combustion. One of these is proposed by India and Belgium, another Italy and Kenya, and another by China and Japan. 2 experiments are about space life science and biotechnology. A proposal by Norway, France, the Netherlands, and Belgium involves tumors in space. Another by Peru and Spain is on the effects of microgravity on disease-causing bacteria. There's also a proposal on earth science by Mexico and a space technology proposal by Saudi Arabia.
Now let's talk with Tricia LaRose in Norway. She is the researcher at the University of Oslo's Department of Community Medicine and Global Health. She is also a member of one of the international teams whose scientific experiments have been selected to fly on China's space station. Very nice to talk to you. The name of your project is Tumors in Space. Can you talk about your programs and why these experiments have to be done in space?
Sure, thanks for having me. Tumors in Space is the most advanced cancer research experiment ever conducted in outer space. Chinese scientists on a previous Shenzhou mission have shown that spaceflight may slow or stop the growth of cancer. The fact is, there is no cure for cancer. It affects everyone all around the world. We've done everything we can on the ground to cure cancer. Now it's time to cure cancer but in outer space.
Wow, let's very look forward to any of the results coming from your research. And what was the selection process like for experiments to be included in China's space station?
The selection process was of the highest international standards. We underwent several rounds of scientific and technical review. Working with the China Manned Space Agency has been excellent, but also working with the United Nations gives us some confidence that we are accessing space for peaceful purposes and for the benefit of all humanity.
Yes, and why did you choose China Space Station as your partner to carry out this experiment?
I personally have a long-standing relationship with China through the International Space University, but also experiments selected for flight on the CSS had to be cutting edge, absolutely new, never been done before, and that is tumors in space. Of course, it's scientifically very exciting to be conducting research on humanity's newest space station and one that is so technologically evolved.
Thank you so much for being with us, Dr. LaRose from the University of Oslo. The foreign astronauts done global cooperation on scientific experiments are most welcome in China's space station once it begins operation in 2022. And these were the remarks made by Hao Chun, the director of China's Manned Space Engineering Office, in an exclusive interview with CGTN.
Since the implementation of the project, we have carried out extensive exchanges with a large number of national and regional space agencies, such as Deutsche Aerospace, the Italian Space Agency, Aerospatiale, and Pakistan's Space Agency. We and the United Nations Office for Outer Space Affairs carried out cooperation on applications concerning the use of China's space station. We signed an agreement. In the early stage, we jointly selected the first batch of projects to collaborate on. There are now 9 projects to be participated in by 17 countries, who have officially confirmed their participation in scientific experiments in China's space station. In the future, there will surely be foreign astronauts participating in China's spaceflight, working and living on our space station. In addition, some foreign astronauts are already participating in Chinese flights and are already learning Chinese.
And joining us in the studio is Professor Yang Yuguang from China Aerospace Science and Industry Cooperation. Great to have you with us, Mr. Yang, as always. So let's talk about it. Now, in 2019, China announced 9 projects from 19 countries that were selected from 42 applications, making them the first batch of scientific experiments for China's space station. What are the standards for the selection of these experiments?
Well, you see that international cooperation is always very important for not only the China Manned Space Program, but also for the whole China Space Program. So in these selections, we cooperate closely with the United Nations, or actually speaking, the UNUSA, the United Nations Office for Outer Space Affairs, and other organizations. So the most important that the scientific research must be meaningful, so it should be innovative and creative. At this standard, we also face the limitation of the engineering. For instance, we have the standard in the standard racks inside the station, and also we have standard interface outside station for the experiments in outer space. So the experiment design must meet the requirements of these standards. And also there is a very important factor is the period or the schedule. So the development and the design of the experiment must not have the confliction with other operations of the station. And also there are other limits such as the communication, the downlink limits, or the data limited, and also the mass and volume of the experimental instruments.
Now also joining us in the studio via the video link is Mr. Xu Yansong, the Director General in Asia Pacific Space Cooperation Organization. Welcome both. Now this is a question for both of you. What are the kinds of experiments conducted in the space station? Earlier we just talked to this researcher from the University of Oslo. She just talked about his research on the cancer and tumors in space. What other experiments that we can see in the space station?
I think the best environment of the space station is microgravity environment. In that station environment, we can do a lot of things that we cannot do on Earth because of the gravity. For example, we have done this before, and many times using the recovered capsule, which is the crystallization of proteins. This is also for medical breakthroughs and cure of cancer and other disease. And in the same time, we're also doing a lot of things such as biotechnologies, and also space environmental microgravity combustions and aerodynamics and microgravity testing for new materials and new breakthroughs. So all of this requires microgravity environment. And also, as a human mission of the Tiangong, we also have the constant attendance of the astronauts to take care of some of the environmental testings and experiments. So this is also very, very big advantage in comparison with the unmanned missions.
Okay, Dr. Yang, which experiments on board of the China space station impressed you the most?
Well, you may notice that there are multiple racks inside the station, either in the core module or in the experimental modules. Each rack will be dedicated into a certain area, and also there are several racks engaged in which can provide service for multiple fields. You see, that's the most thing impressed me is the microgravity physics, especially the microgravity fluid physics, and also the combustion phenomena in microgravity field. There are also some other research, as Mr. Xu has mentioned, the biological or the medical research on the influence of microgravity and the radiation to the human cells, even the cell of cancers, and also other creatures. What impressed me is some engineering research. You see, that's what we just have mentioned is scientific research. There are also other research on engineering. For instance, the newly designed instruments, devices, even chips, the influence of the outer space environment to them, and to develop new technologies for the future vehicles, even the vehicles to go deep into the space.
And we're now 40 minutes into Tianhe's space flight. We're now standing by for another major move by the Tianhe core module. It currently is flying in low Earth orbit now, and it's going to open solar panel wings shortly. And when that happens, we're going to bring it to you in full. And Mr. Xu, China's space station weighs much lighter, actually, than the International Space Station. How can it meet the international standards?
Well, the international standards are not done by its weight and size. Because the International Space Station is built by multiple countries. The beginning phase, it was 14 countries, including European space agencies, Italian space agency, France, Russians, and US. The biggest segment, and also Japan. The biggest segment, of course, is US and Russia, and also it comprises multiple segments of the fuselage, which was manufactured in Europe and Japan. And also the Japanese Kibo segment also was open for international cooperation in the region. So a lot of countries are participating in that experiment, either internally, like Professor Yang mentioned, the different rankings, and also externally with external experimental facilities. And the station is also capable of deploying small satellites. So once you bring a satellite, mostly CubeSats, into the station, you can have the satellites deployed to the trail of the space station, so the satellite can also operate independently. So there are many things that you can do on board, smaller size or bigger size. We can do similar things. So the Chinese space station is a breakthrough for the Chinese space community, and also number of experiments are recruited and called for announcement of opportunities in the international community. We'll also receive very interesting proposals like from Thailand. Thailand Gista mentioned about 3D printing for astronauts' food. So today, if you fancy for a steak, you can go to the 3D printers to print your steak, and tomorrow maybe another Chinese food. So it can also be done in space. So this is also one fascinating areas that we can look into in microgravity environment, and especially in confined space like the space station.
All right, Mr. Xu, Dr. Yang, stand by. We're going to come back to you in just a bit. China is launching the core module of its space station today, and the station is expected to become operational by the year 2022 and will be the second of its kind to be present in space. Currently, the only space station in orbit is the ISS, or International Space Station, a multinational project that's been operating for 21 years. Now, the ISS is the largest artificial object in space and has been hosting hundreds of astronauts from different countries. Let's now take a close-up look.
The International Space Station is the largest single structure humans have ever put into space. Its components were constructed and assembled between 1998 and 2011. In 1993, the United States and Russia agreed to merge their separate space station plans into a single facility, with assistance and components from a multinational consortium including Canada, Japan, and 11 member states of the European Space Agency. The first component of the International Space Station was launched on a Russian rocket in 1998. More pieces were added after that, and 2 years later, the station was ready to host astronauts. The first crew arrived on November 2, 2000, and humans have been staying there ever since. The space station flies at an average altitude of 400 kilometers above Earth. In one day, the ISS travels about the distance it would take to go from Earth to the Moon and back. The space station is as big inside as a house with 5 bedrooms. It has 2 bathrooms, a gymnasium, and a big bay window. It weighs 391,000 kilograms and is big enough to cover an American football field, including the end zones. It also has science labs from the United States, Russia, Japan, and Europe. The International Space Station is making discoveries not possible on Earth and helping us push further into space.
Every single day, we are answering big questions about Earth and about space, about where we came from and about where we're going. But the other thing that we're doing is we're learning more questions to ask.
The Alpha Magnetic Spectrometer 02 has been looking for evidence of dark matter from outside of the space station since 2011. The one-year mission conducted between 2015 and 2016 was the first of a series of extended duration research missions to develop a better understanding of how each human system adapts to the space flight environment. In 2018, NASA's Cold Atom Lab became the first facility to produce the 5th state of matter, called a Bose-Einstein condensate, in Earth's orbit. The space station is a home in orbit. People have lived there since the year 2000. Current plans call for the space station to be operated through at least 2024, with the partners discussing a possible extension until 2028. After that, plans for the space station are not clearly laid out. It could be deorbited or recycled for future space stations in orbit. But humans will not stop exploring the unknown and the endless universe.
Let's continue our discussion with 2 of our guests. Dr. Yang, compared to the International Space Station, what are some of the new features that we can expect from the station of China that China is building?
Well, you see that the International Space Station is the 4th generation of space stations, compared with the Mir station, because Mir is the 3rd generation which adopted a modular design. And based on this, the International Space Station has a very big truss. The main truss has a length of 108 meters, and we can see 8 pairs of huge solar panels, which have 2-dimensional SADA, or solar array drive assembly. Well, our station, as Mr. Xu and you mentioned, it is much smaller than the International Space Station. This is because you see that we are still developing country, so we don't choose to have such a big station, and we only build a station which can meet meet our requirement of high technology development and scientific research. So, although this station is much smaller than the International Space Station, but the efficiency of the station is higher than the International Space Station. It also has the huge solar panels which have 2-dimensional SADA, or solar array, so it can rotate in two directions and provide very powerful electricity, usually higher than 27 kilowatts to the station. So it can perform many research. You see, as I mentioned, there are more than 20 standard racks in our station. not very, you see that only the International Space Station only have 40 racks also. So we can do a lot of things and more scientific research than the Mir space station. Even you see that in this initial stage, we only have three modules, less than the half of the mass of Mir, but we can do more scientific research than the Mir. So we also belong to the fourth generation of space stations.
And Dr. Xu, over to you. The International Space Station has been in service since 2000. It is expected to retire until 2024 unless plans from the participating countries, mainly US and Russia, change. But do you think that China's space station can somehow replace the ISS? Because if the ISS retires, the China's space station will be the only one left in space that is functional.
Well, I think the ISS is not going to be completely retired or burned out in outer space atmosphere because the International Space Station is a huge complex and still retains its value in outer space. So the retirement by 2024 means that the intergovernmental mechanism is disassembled so that this station can be either commercialized or separated. So that national support would no longer be available. So the Chinese space station will be an important supplement to the International Space Station with a continued effort from the government support and also a continued presence of human beings in outer space. I think the International Space Station is seeing some agings, but also it's still vital for future missions, including the moon missions. They're doing a lot of experiments on the International Space Station in preparation of human lunar missions as well as Mars missions. So the International Space Station remains an important infrastructure with a substantial supplement of the Chinese station. So both are going to work in parallel and for a period of time, I think.
And Mr. Xu, you mentioned about burnout procedure of the International Space Station. According to the Outer Space Treaty, the United States and Russia are legally responsible for all modules they have launched. So can you tell us a little bit more details about what are their disposal plans after the ISS retires?
Well, that's a very good question you mentioned about the Tiangong-1 and Tiangong-2 as well as the International Space Station burnout. Tiangong-1 was uncontrolled reentry. So it was very close to a damaged area, but fortunately it landed in inhabited areas, so it was very safe reentry. On board the International Space Station, if they want to burn up some of the segments, they can do it in a controlled manner. They can drop those cargoes or the segments they don't want to use anymore. They can re-enter into space, and they can design the trajectory so that it will drop in the Pacific or some areas that is less populated or even no populations, so it can drop into the ocean. But some of the hardcore stuff would sustain the burn. For example, the glass, the ceramics, and some of the metals that they can really withstand the re-entry of burning. Unlike other materials, will disseminate and fragment it in the re-entry process. So some of them will survive. So we have to design the process in such a fashion that we have joint observation of the ground facilities, and it will drop in the same area, a safe area that is not inhabited by human activities. So the dropping of the International Space Station is not being planned at this moment. I think the first thing is to look at the value of the International Space Station, the amount of money it costs to maintain the station altitude and the control of the station, as well as the commercial aspect of the International Space Station.
And Dr. Yang, I want to get your take on the international collaboration, right? China is saying that it welcomes collaboration on the Chinese space station from scientists from all over the world, but the level of international collaboration that the CSS will receive, according to an analyst, will be unclear due to geopolitical hurdles, noting that U.S. law places very heavy restrictions on NASA scientists cooperating directly with China. So how are you looking at this, the prospects of international collaboration?
Well, you see that according to the White Book of China Aerospace Activities and also according to the announcement of China Manned Space Agency, the international cooperation will be one major part task of our space station. There are 4 levels. The first is a joint experiment. As you see, it's extended.
That's the replay. That's the replay there. And also talk to us about this telescope that we're going to be joining the Tianhe module. A report says the Hubble Space Telescope will last through the mid-2020s. What are some of the significant contributions it has made to the study of outer space?
What you mentioned is the Xuntian module. Originally, it is part of our station. It is the original experimental module 2. But finally, we decided to let the Xuntian to fly independently. So the Mengtian takes the place of the Xuntian as the experimental module of 2 of our station. But the Xuntian will stay in the same orbit of our Tiangong space station. In certain cases, it can be docked to the station, and the astronauts can keep some maintenance and repairing tasks. So this is very convenient. Comparing with the Hubble Space Telescope, you see that the aperture of the main mirror of our Xuntian is 2 meters. The diameter is 2 meters, only a little bit smaller than the Hubble Space Telescope. But with the new technologies, we can do more things than Hubble. And the most important, it's much easier than our Xuntian to be repaired or be maintained by the space station, rather than the space shuttle taking the maintenance and repairing task of the Hubble.
Yeah, what kind of the international cooperation do you guys are expected to see in the future when China completed its construction of the space station? Because we just talked to Dr. LaRose. I think that was a great example to illustrate how important this kind of international cooperation is in this era of space exploration. Mr. Xu.
Well, I think international cooperation is very important for all missions in China. We have also very prominent mission of the Chang'e missions. The Chang'e 4, as a redundancy of Chang'e 3, has collected 5 or 6 countries to put on board the Chang'e 4 instruments. For example, the neutral detectors from Sweden Institute of Space, and also many of the instruments from Europeans are flying on board the Chinese missions. This will be also true for the Chinese space station, because we want to make sure that developing countries, not only countries that have space powers like US and Russia, but also developing countries among the international community, in particular Belt and Road Initiative, can also benefit from the space activities and space ambitions from China, so that the experiments also have the inclination of going to that direction of collecting proposals from those countries. So international cooperation is an essential part of the space activity in China.
And these experiments, space technologies we were talking about, Mr. Xu, they have benefited humanity a great deal, right? For instance, the intelligent control technology developed for rockets has been applied in construction of smart ports, communities, factories. Diapers were initially designed for astronauts in space. Talk to us about these benefits.
Yeah, space technology has been derived in many areas, but also, for example, the CT scanners, as well as many MRI, medical imaging facilities, are also technologies that are derived from space technology. So we see a lot of space benefiting our daily life. For example, the communications that we use for TV broadcasting, overseas communications, navigation on our cell phones, or even in the car, that we use almost daily and rely more and more on it, has been taken for granted, because those are space technologies that are benefiting our daily lives. There's a saying that if you switch off the space for one day, you won't tell the weather, you won't have a navigation, you won't know your way back, and you won't communicate anyway. So it's back to the Stone Age, basically. So space technology are very important for our daily life, even though we take it for granted, because we can't see it visibly with our eyes, but we do feel it and we do use it.
Yeah, we're now about a little more than an hour into this flight, and we're still standing by for that solar panel deployment.
Yes.
And you're looking at this clock right there in the command center, an hour into this flight, about 3,500 seconds. That is measured in seconds. And Dr. Yang, the European Space Agency is cooperating with China on the space station, and there's also support from the United Nations Office of Outer Space Affairs. Talk to us, why is it necessary to secure international cooperation even before the construction of the space station?
Actually speaking, you know that our manned space activities and our lunar exploration projects and even our Mars missions is getting some support from other countries. You see that during the first several missions, the European Space Agency provides support by utilizing their ground stations all over the world. Because you know that although China is a big country, but still very small comparing to the whole globe. Well, during the flight missions before we have our Tianlian data relay satellite, the coverage of our ground stations are still limited. So we really need the support from other countries to get the ground stations, the data link from the stations of other countries. And also, as Mr. Xu has mentioned, we have payloads from other countries. Especially, I should mention that you know that Shenzhou 8 is a manned mission to test the rendezvous and docking technology. But on board the Shenzhou 8, there is a joint experiment between China and Germany called Singbox, which performs some biological experiment in space. So these have very great achievements and have benefit to the science, to the space science, and also to the benefit of the whole human society. So in the future, you see that the international cooperation, to my understanding, is already a major trend in the whole world, not only in China, but also in other most space-capable nations. So we should do this more in the future.
Well, Mr. Xu, I got us a question, because this projects have been involved so many international organizations inside, including the UN Office of Outer Space Affairs, including the European Space Agency. Can you tell us more about this kind of a cooperation with those international organizations?
Well, the United Nations Office for Outer Space Affairs is the functioning part of the United Nations Committee on Peaceful Use of Outer Space. And also they're the governing body of the implementation of the Space Treaty. So it's more or less of the largest multilateral platform that is currently functioning in UN for space areas. The COPIOS, or Peaceful Use of Outer Space Committee, has over 80 member countries from all over the world. So we're using that platform to place this announcement opportunity. So this is one of the words that we use mostly for once you have an opportunity to cooperate in space. So we announced that the Chinese space station is open for cooperation and proposals. So that platform has been functioning with the United Nations Office for Outer Space Affairs. That many countries did express their interest in participating in the payload on board the Chinese mission. And also with the European Space Agency, we have cooperated in many years. That is based on the telemetry tracking and control cross support. That because of the geographic locations, we did receive a lot of support from ESA, including the lunar missions. And as well as the deep space exploration missions.
Sorry to interrupt there, Mr. Xu, because we're entering a critical point. The solar panels, looks like the solar panels on the Tianhe core module, they have successfully deployed. You're seeing that solar panel wings stretching out from the main core. How critical is this, Dr. Yang?
You see that we can see from the screen, this is a 3D animation. Although it is an animation, but the status, what I mean is the status of the solar panels is based on the telemetry data getting from the downlink. So you can see that we can sure that this status is confirmed by the data getting either from the ground tracking, space tracking ships, or from the Tianlian data relay satellite. So you can see, we can confirm that the solar panels has been unfolded properly.
Yeah, another major move completed by Tianhe core module. And obviously, after the space station is completed, we will send astronauts up to space, right? So let's talk about this. China has selected 2 rounds of astronauts already. It now has, what, like 17 active astronauts? 11 of them have flown into space. And the country is now about to select a 3rd round of astronauts. And they used to come from the Air Force only, right? But Mr. Xu, I'm hearing that civilians now can apply to these missions as mission specialists. Is it true?
Well, selecting astronauts from Air Force has simply because of the physics and the conditions that they have flown. But I think in the future we will select astronauts from the common community based on scientific backgrounds. This is also true in NASA. Once they have the space station and shuttle, they used to select people from the Air Force, and then followed by a number of astronauts that are basically with the scientific background, so they can do more and understand more of these onboard missions.
And Mr. Xu and Dr. Yang, in the following stage, astronauts crews will be sent to the space station by taking Long March 2-5. And a space official said in March that there will be another Long March 2F rocket to stand by in case there is an emergency rescue mission. Tell us more about those safety procedures.
Well, you see that the Long March 2F for the launch of Shenzhou 12 has already arrived at the Jiutian Satellite Launch Center. But before that, we should perform the Tianzhou 2 mission. The launch of the Tianzhou 2 will be performed next month, and docked to this Tianhe core module, which can provide the most of the supplies for the 3 months residence of our Shenzhou 12 crew members in this station. So, so maybe in June, the Shenzhou 12 will be launched and bring 3 astronauts into this station, and they will coming from the front docking port, entering the station, and then open the hatch of the rear part of the cargo ship and bring the supplies from the Tianzhou 2 to this station. And also we will have the EVA spacesuits, 2 of the EVA spacesuits improved from the original Feitian spacesuits to test the EVA technologies during this mission. And as you mentioned, I think this will be a routinary preparation in the future. Yes. In every moment, there will be a Shenzhou spaceship and the Long March 2F rocket in the Jiutian Satellite Launch Center acting as a rescue, as a backup for rescue missions. But if the former turn of the astronauts is safe, so this rocket and this Shenzhou spaceship will be used for the transportation of the next expedition team.
Yeah, that reminds us that it's still a very it's very risky activity in space. And Mr. Xu, can you just brief us a little bit of history on, did we see any of that kind of emergency rescue missions that has been carried out before in the history?
Well, we've seen the movie Gravity, but we haven't seen this reality. But we did have some emergency. Yeah. We did have some emergency with the Russian Mir station. Once it has a fire on board, it was a very tense moment. You have to see, you know, because of the high risk of the oxygen on board. So the fire is very difficult to contain on board the station. So it has to use extra caution when you're operating in orbit some 400 kilometers above the Earth, and also be prepared for a emergency escape using the capsule at a time. So it occurred once or twice in station, but it was not fatal at that moment.
Yeah, and for those of you who are just joining us, we are 70 minutes into Tianhe core module's flight, and you're now watching at a 3D animation that is showing you what is happening in real time. You can see the solar panel has been successfully deployed from the Tianhe core module. I mean, this is a mission 29 years in the making, but eventually China is planning to send human onto the moon and eventually onto the Mars, right? Dr. Yang, talk to us about the moon mission and Mars mission that's going to follow this.
Well, you see that the China National Space Administration has announced that our Chang'e 6 will land in the South Pole Aitken Basin on the far side of the moon. Very soon. You see that originally the Chang'e 6 is the backup of Chang'e 5, but the Chang'e 5 is already been successfully accomplished, so it has a new goal to land on the far side of the moon and get samples back. This is very important, very meaningful for the preparation of setting up a scientific research station in the South Pole regions, as announced by China National Space Agency and the Russian Space Agency to have a joint missions in the future. So the Chang'e 6, 7 and 8 will be recognized as a preparation for setting up this ground station on the lunar surface in the future. And also, if the Tianwen-1 Mars mission can be successful landed on the Martian surface, in the future, we will have sample return missions within this decade. So, you know that until now, there is no other countries in the world that have completed sample return mission from the Mars, because it is really, really difficult. So I hope that this can also be successful. In the future, China also plans to have the missions to the asteroids and to the Jupiter and its moons, or even beyond, to the Uranus or Neptune. And for the manned space programs, you know that our space station can work in space for more than 10 years. And during this period, we are also preparing for our potential human missions to the moon. And you see, last year we launched the Long March 5B like this launch. It is a test launch. So we also tested the new generation spaceship, a test module. This module can be recognized as the rudiment of the future spaceship, bring our astronauts to the moon.
Yeah, we did get a view of the audience who are watching this flight very closely. One at Beijing, at the Beijing Aerospace City. The Premier of China, Chinese Premier Li Keqiang, was there, and Wang Huning, Standing Committee of CPC Political Bureau, was among the audience. And also, we got a view of the audience at Wenchang Launch Center. Mr. Zhang Youxia, he is the Vice Chairman of the Central Military Commission, was among the audience.
And Dr. Yang, as you mentioned before, that a big threat for the astronauts is the cosmic radiation. And our spacecraft is flying, the space station is flying at about 400 kilometers orbit. And just the 200 kilometers above them is the radiation belt of the Earth. And we know this radiation belt will be held in position because the magnetic fields of the Earth can't hold it. It's strong enough to hold it in position, but it's not evenly distributed. The strength of the magnetic field is not evenly distributed. And some reports mention that some part of the radiation belt is getting weaker and weaker and is falling down. And some part of that on the Atlantic Ocean region has already sank and drowning into the atmospheres. Will that harm our astronauts?
What you mentioned is SAA,
yes,
which is located in the South Atlantic Ocean.
Yeah.
At this region, the radiation is much stronger than the other regions even in the same altitude. So we have considered this influence, and also the astronauts is well protected by the space station. But we do see similar phenomena of the influence of the radiation. You see that. Some of my friends are the Apollo astronauts, yes, who have visited the moon. You see that for the Apollo missions, they must coming across the radiation belt.
That's
they
right.
say that during the crossing of the Van Allen radiation belt, they can feel flares in their
when
eyes.
When they close their eyes, they can see the
yes,
flash.
But because this is only a very short period, so do not have some hazards to their health. But for long-term residents, it is a different matter. So we must consider this. And also, it is very interesting that there are also influence of this radiation to instruments. Yes. For instance, to measure the accurate attitude of a spacecraft, we need star sensors. Mm-hmm. In some cases, especially in what you mentioned, the South Atlantic Ocean, some of the star sensors cannot work because of the high energy particles also have images on the CCD.
All right, you're looking at the live picture from the Beijing Aerospace City. Premier Li Keqiang and the member of Standing Committee of CPC Political Bureau, Mr. Wang Huning, was among the audience, giving a round of applause after seeing successful deployment of solar panel wings. And Dr. Yang, what are we seeing here?
Yes, look, you can see that there are two cameras on board the station. We can see the video from the cameras. Now, especially from the screen on the left, you can see that this camera shows that the huge solar panels has been extended properly. Mm-hmm. And this means that it's this moment the station is orbiting the Earth under the sunshine. So we can see, we can have these videos from the station. This proves that the solar panels have already provided the electricity to the whole station, not depending on the storage batteries. So the station can go on its task continuously.
Yeah, there are numerous cameras on this capsule, right? And they have light on it to illuminate the spacecraft so that it shows up on camera. They can use it for engineers if there to be a problem or anything. They want to have cameras on all the parts and components like this one, providing you this view. In case there's an anomaly, right, it can be a good visual representation or a good reference of what's going on.
That's right. Mr. Xu, there are 5 docking ports on the core module of the Tianhe, which is what we're watching right now. It is reportedly prepared for 2 docking ports, 2 berthing ports, 1 EVA hatch, and what are they?
Well, I think this comprises the connecting parts.
That is the live picture coming out at the Wenchang launch site. People are cheering and applauding. You're watching the command. Vice Chairman of Central Military Commission
the
making an
honorable
announcement.
leaders,
Let's listen.
experts, dear colleagues. According to the report, the Long March 5B Y2 carrier rocket has already lifted Tianhe core module to the scheduled orbit, and it's also having normal function. And I declare that the mission of Tianhe core module is a complete success. Now, let's give the floor to the Deputy Chairman of the Central Military Commission, Zhang Youxia, to read the congratulations of General Secretary Xi Jinping. The space station and its headquarters, and as well as all of those organs and departments responsible for this mission, and dear colleagues in charge of this mission, on the occasion of a complete success of the launching of Tianhe core module, on behalf of the Central Military Commission, CPC Central Committee, and the State Council, I would love to give my congratulations to all of you. Establishing the space station and the space laboratory is one key step of the 3-step strategy, and it's also one necessary step to establish a strong space and astronautic power. And the success of today's mission signifies that we have entered into a comprehensive stage of space development. It lays a solid foundation for future missions. I hope all of the staff members could further carry out the spirit of atomic, 2 bombs and 1 satellite, and have a complete success of the space missions, and contribute to building a modern society with Chinese characteristics. Xi Jinping, April 29, 2021.
There you have it. Mr. Zhang Youxia, Vice Chairman of the Central Military Commission, an official confirmation for the command center. The launch is a success. Again, the launch of the Tianhe core module is a success. And China has successfully sent the core module, a space station, into orbit. It is going to stay there, waiting to be joined by other modules till the space station is fully assembled in space. And later this year, is going to be visited by Chinese astronauts as China's manned space programs continues to move forward.
And in addition to the Tianhe core module that has been launched today, that China is planning to at least 10
of the space station.
Well, in addition to this Tianhe today, we are expected to see more missions to be carried out. China is planning at least 10 more launches of other major modules, as well as crewed and cargo missions, as Shuya mentioned.
All right, that is Premier Li Keqiang. You're seeing there, shaking hands with all the engineers, followed by other officials. And because of the pandemic is under control now in China, shaking hands is no longer a taboo. We have to mention that.
Yeah.
congratulating the team of a successful launch.
They have been working on this project for decades, and they just just have a good start today.
Yeah, what do you think is going through their minds, Dr. Yang, after this successful launch?
Well, this is a really great milestone, not only for the history of China manned space activities, for China's aerospace, but for the history of the whole country and for the whole world. I can still remember 10 years before, in the 29th of September, in the studio of CCTV News, your colleague, Mr. Zhou Yue, said that today we are one step closer to have China's own space station during the live coverage of the launch of Tiangong-1.
That is the live picture from Wenchang launch site. The officials there shaking the hands with engineers, congratulating them on their hard work. What a historic day for China's manned space mission.
Yes. And today it becomes into reality.
Yeah, it all starts from this moment, right?
But it's just a beginning.
And a good beginning as well.
Yeah.
And we have to mention that China is now the world's second space spender and has launched the most rockets since 2018. Mr. Xu, let me bring you into our discussion. Why is China seeing it as a national priority?
Well, I think we see an increasing number of space activities in China. In particular, last year we had more than 39 launches. By that we mean there's another one from the lunar surface, ascending vehicle, putting samples back to Earth. So that's in total 40 launches. Activities increase because we need to build space infrastructures. We also have more ambitious space projects and programs. We know in the past US and Russia had more than 1,000 launches each country. But we're catching up. We have more than 300 and 400 launches, and also we have booming commercial sectors in the space areas. So space has been areas that is very intense development. This is largely due to the development of the economy in the nation. Every country space activities and space ambitions are reflected by their GDP.
Yeah, Mr. Xu, let's just review what's going to happen in the rest of this year. What we expected to see.
What's next, right?
Yeah.
Exciting parts is the building of the CSS, the Chinese space station. This will be followed by next month cargo ship and manned crew in the months to follow, and 11 launches in total. So this has been delayed somehow because of the Long March 5 hiccup 2 years back. So the space station is supposed to finish in this year. So we're delaying that for 1 year, but we're having intensive launches of the space station. This year we're also going to see exciting moments that in May or June we'll have a landing mission on Mars. So this has been just newly named, the lander and the rover. So it's a single mission with multiple purpose. We successfully inserted the orbiter into the Mars orbit. And this year we also had this lunar sample return mission successfully bring back 1.7 plus kilos of lunar sample for the first time in Chinese history and for the first time in 40 years. So exciting moments are also looking into the construction and the launching of the Chang'e 6, which is on the South Pole. We're going to see in situ resource lunar volatiles in this mission, and also lots of international collaborations in these areas and beyond.
Thank you so much for two gentlemen to sharing this the insight with us today. And that's Professor Yang Yuguang from China Aerospace Science and Industry Cooperation, and Mr. Xu Yansong, the Director General in Asia Pacific Space Cooperation Organization.
Yeah, thank you. And that is all for our special coverage today. And we will leave you with some of the key moments from the Tianhe core module launch. And I'm Li Qiuyuan.
And I'm Yan Zhao. Thanks for watching, and stay tuned for more news coming up in the minutes with my colleagues Li Dongning. Bye for now.
5、4、3、2、1，点火！点火！